All right, now we've got the Unit 2, Objective 3 notes, solving and graphing absolute value inequalities. Okay, let's dive right in. So, like it says here, most of the time when we solve an absolute value equation, okay, now that's the keyword there, is an equation, because then today we're going to be dealing with inequalities, which is a greater than or less than sign instead of an equal sign. But when we have an absolute value equation, we normally get two answers. Okay, if our equation equals 0, sometimes we'll get one answer, or we can have no solution. Okay, but most of the times we solve an absolute value equation, we're going to get two discrete answers. Like it says here, most of the time when we solve an absolute value inequality, we will get, and there's different ways to say it, but we're going to get a range of answers. Okay, now a range doesn't mean like domain and range. What it means by a range of answers is like a variety of answers. Okay. All right, now just like in Objective 2, we're going to look at our solutions both from a graphing and an algebraic perspective. Okay, so here, let's take a look at the algebra part first, kind of like we did on Objective 2. So we've got two functions, f of x here and g of x there. We want to graph those on the same set of axes and then also solve algebraically. Okay. Now, like it says here, our general rule for when we have a problem that looks like this, the absolute value of something is less than our answer or less than or equal to. We want to do what we call, like it says here, what I like to call, we want to make a sandwich, basically. I'm going to put make a sandwich. Okay, so you're going to hear me refer to that as a less than sandwich a lot of times. So anytime it's a less than problem, we're going to make a sandwich. When it's a greater than problem, so if this was flipped around, we would do something else. Okay, so how do we make our less than sandwich? Well, just like it says here, we want to put whatever's inside the absolute value bars in the middle. We're going to have our inequalities facing the same direction. Okay, so they both read less than. And then we want the opposite of our answer on the left side, and then our answer on the right side. Let me try to clear this up just a tiny bit. Okay, so if I'm going to make my less than sandwich for this equation, because it's a less than equation, part of my answer is going to look just like this. I want to know when is this stuff less than my answer. So it's going to be like this. Okay, so the first part of your equation looks just like the original equation without the absolute value bars. And then just put another set of less than or equal to bars on the other side. Not bars, but a symbol there. And then the opposite of your answer on the other side. Okay, because I want to see when does this stuff come out less than or equal to 5 or greater than or equal to negative 5. Okay, all right, and then we want to solve this. We can solve this whole equation at the same time by adding 1 to all three parts. And then when I do that, the middle part's the important part. That's what we want to focus on. We want to get x by itself. So then, yeah, that gets me x by itself. And then I get x is less than or equal to 6, and then greater than or equal to negative 4. So then those are my answers. Okay. In other words, the absolute value of what is less than 5? Well, 4 will work, or 3 will work, or 0 will work, or negative 1 will work, or negative up to negative 4 will work, or negative 4.9, all that stuff. So when is this stuff going to equal all those numbers? Well, when x is between negative 4 and positive 6. Okay, so then those are our answers. If we graph that on a number line, what would that look like? Okay, so our number line. Well, what 2 points do we really need on there? Well, just negative 4 and positive 6. I'm going to put a closed circle because I am including negative 4, and a closed circle because I am including positive 6. And then what numbers do I want? Do I want just those two numbers? Well, no, we want everything less than negative 6, so that's all the stuff that goes that way, and then greater than negative 4, all the stuff that goes this way. So then if you look at the number line, you can see that, yeah, your answers are, again, sandwiched in between these 2 points. Okay, so again, that less than sandwich, our answers should be sandwiched in between 2 numbers. Okay? All right, then next, let's look at the graph. So how do we graph these two functions? So if I'm graphing f of x by itself, it's an absolute value function, so it's going to give us that V shape. Our vertex would be at 1, 0. Our A value is 1, so I'm going to go up 1 over 1, up 1 over 1. And then I could graph it just based off of those 3 points. Let's throw some more points. I'm just going to throw several more in here. by going up 1 over 1 in each direction a few times. And then now I can draw my v. So it would look about like that. Next, my function g of x, just the line y equals 5, so that's a horizontal line up 5, so 1, 2, 3, 4, 5. Would look like that. Okay, and then they said highlight or darken the portion of g of x where f of x is less than g of x. Okay, now let's kind of translate that a little bit. Which graph is f of x? Well, f of x is my v, and then g of x is my line. So then where is my v less than my line? In other words, where is my v below my line? So that's what we want to highlight. So that's going to be this part of my graph here. So all those parts highlighted in yellow will make this a little bit thicker here. Okay. And then what x values are on all those points between here and here? Well, this is x is 1, x is 3, x is, all the way up to x is 6, and as far back as x is negative 4. So just like our algebraic answers, between x values of negative 4 and positive 6, that's when my absolute value function is going to be below my line, less than my line. Okay. All right, so there's example 1. Let's take a look at example 2. Okay, so very similar. They're giving us two functions, f of x and g of x. We want to compare their graphs and then also solve algebraically. Okay, now the biggest difference here is if we look at our equation, which they already set up for us. This is a greater than problem, not less than. Okay. Now, just like in objective 2, before we go set up our equations, whether we're making a less than sandwich or the other case which we're going to look at here, we want to get the absolute value part by itself. Okay, so let's start with that because we want our equation to look how we want it to. So I'm going to add 3 to both sides. And if we do that, we get the absolute value of x minus 1 is greater than or equal to 6. Okay. All right, now that I have it set up how I want it to, how do we set up our equation? So this time they didn't write it for us, but like it says here, if we have a greater than problem, so the absolute value of something is greater than our number, like this problem is here, we want to set up 2 cases. The first case is going to look just like that. Just get rid of the absolute value bars. I want to know when is the absolute value of this stuff greater than my answer. So in other words, it's just going to be x is greater than or equal to my answer. And then the second case is I want to know when is this stuff less than or equal to the opposite of my answer. Okay, so again, your first equation looks just like that. Just get rid of the absolute value bars. And your second equation, you want to do 2 things. You want to flip the sign around and make your answer negative. Okay, and then that's how you set up your 2 cases, and then that allows us to solve. Okay, so let's go ahead and solve this one by setting up our 2 cases. So my first equation is going to be, I want to see when is x minus 1. When is that greater than or equal to 6? Okay, because if this stuff comes out greater than or equal to 6, then yeah, it's going to be bigger than 6. Okay, and then if this stuff comes out less than or equal to negative 6, well then when I take the absolute value of it, it's also going to be greater than 6. So again, the second case is I want to see when does my stuff, x minus 1, less than or equal to negative 6. Okay, so now I have my 2 equations. Sorry, I staggered them a little bit. But let's solve these things. Now if you want to, since the left side of the equation is always going to be the same, you can solve these at the same time because you want to do the same steps to get x by itself. So we want to add 1 to both sides in each of our equations. And then we get x is greater than or equal to 7. That's going to give us one range of answers. And then x is less than or equal to negative 5. That's going to be our other range of answers. Okay, so then these are the 2 scenarios that are going to give me answers that make this equation here come out true. Okay, so if we graph that on a number line, what does that look like? All right, so let's see, we got positive 7. I'm going to put that over here. Closed circle is fine because it's greater than or equal to. And then negative 5, I'm going to put somewhere on the left. Okay, and then let's see, I want x values greater than positive 7. Well, greater than is going to be going to the right. and then x values less than or equal to -5, that's going to be all the numbers to the left of -5. Okay, so when we have a less than problem, my answers are all sandwiched in between these two numbers. But when we have a greater than problem, my answers are going the opposite direction. I want everything except the stuff in the middle. Okay, so quite the opposite of the less than problems. Okay. Next, let's take a look at the graphs. So if we graph the absolute value of x minus 1 minus 3, well, that's going to have a vertex right 1 and down 3. My a value is 1 again, so I'm going to go up 1 over 1, and I'm going to do it several times just so I can get a decently straight line. And same thing on the other side. Okay, so a lot more points than I needed, but now we can graph our v. Okay, so it'll look about like that. And then next, I want to draw the line y equals 3, because that's g of x. So I'm going to go up 3, and then draw a horizontal line. Okay. And then next, highlight or darken the portion of f of x where f of x is greater than g of x. So again, f of x is our v, g of x is our line, and greater than basically means above. So we want to highlight where our v is above our line. So then where is the v above the line? Well, right here, and it looks like a small section, but remember that goes out forever. And over here, which also goes out forever. Okay. So then what x values does that cover? Well, anything bigger than 7 or anything smaller than -5. Okay. And that is page 1.